Learning about security doesn't need to be scary.
If you want to ship code securely with confidence, check out the URL below and challenge yourself with thousands of challenges in 29 coding frameworks. Let the games begin.
Hello everyone. So our next talk is going to be How Do I Content Security Policy by Kirk. So welcome, Kirk.
Thank you. Thank you very much to the person that started off that round of applause. So my name's Kirk. Excited to be in your overly hot city. I'm from Wellington. The bit that was familiar this morning was the wind, so it was nice. Today I'm going to be talking about content security policy. So if you've ever received a penetration test, the pen tester will stick in a finding like, please implement content security policy. And then you'll find out that it's way harder than that one line they wrote, which is kind of true of everything they write in a pen test report. But content security policy is particularly difficult. So I thought I'd do this talk to kind of wrap up a couple of different approaches that you can use and give some advice. But first, before we do that, we're going to do a little exercise. And not physical exercise, because I don't do that. This is, I'd like you to grab a piece of paper. For the young ones in the room, back in the old days, we used to chop down trees, roll them out flat, write on them once, and then throw them away, and we'd call that paper. So if you just grab one of those, roll it up with some columns, and in the first column, just write down a list of all the websites or web apps that your company protects. Who's got more than like 5 on their list? Yeah. Okay. So just pick a handful of them. I'm going to pretend that you're doing this exercise. So put ticks next to the ones that you need to log in order to access, and put ticks next to the ones that have sensitive data. So, maybe you need to log into the system, but it doesn't really matter. It's just the blog or something like that. Or maybe it's the finance and salary of your employees, so it's real sensitive. So obviously the stuff that you need to log into and it has sensitive data is probably the stuff you'll most want to protect, but just give them a ranking, and then you can take this back to work with you and go, oh, this is the thing I'm going to do on Monday. It's going to fix finance.internal.example.com. These are the ones that you really care about with cross-site scripting. So if a site doesn't have sensitive data, doesn't have login, then who really cares if it's got cross-site scripting issues? I mean, it's a little bit embarrassing, but no one can steal your stuff. So focus on the ones that do have sensitive data. And then I also want you to think about which ones do you have source code to. So you might have the source code to WordPress, but can you actively fix bugs in it yourself? Like, is it under active development by your company? Or maybe you don't have the source code to something important that's in your company, and you can't fix issues yourself. Or maybe you do, and you're lucky enough to be able to fix them. And so these are the applications that are high risk for you, right? Because they've got sensitive data. You have to log in to see it. It's that secret. But you can't fix the issues yourself. And if you get cross-site scripting issues in applications that you can't fix yourself, it's quite disempowering. And you need to come up with another approach. So content security policy is a bit of an approach you can try. And I've written a book. So you don't need to take photos of this talk. The slides will be, or the book will be published on the conference website. Published author of a book. So who here has read a Pick a Path book as a child? Yeah, old people in the audience. Yeah, so for the young people in the audience, before hypertext, what you'd do is you'd be reading this book and you'd get to the end of the page and you'd have to make a decision like, do you pull out your sword and try and kill the dragon, or do you run away? And if you had to kill the dragon, you'd turn to page 30, and if you wanted to run away, you'd turn to page 7. And so you'd kind of like flip your way through this book, going from section to section, back and forward through the book. And the great thing was, like, it looked like you were reading a 200-page book, so your teacher thought you were really smart, but actually it was only 20 pages or something, because most of them were paths that you never went on. And so, you're reading the Pick a Path book, and then like you get to the page that says you're dead, you've been eaten by a grue, and you're like, oh crap, now what do? I have to start the whole book again and try and take a different path. So quickly you realize that you needed the equivalent of the back button in your browser. So you'd put a finger in the last page you were in before you decided whether to kill the thing with a sword or run away. And then if you ended up dying, you'd flick back. But then you didn't really know if that next step, so you put your finger there as well and you go to the next page. And so you end up reading this book with like all 10 fingers in it and kind of this undo stack where you'd... Okay, I can see that the old people in the audience are, anyway, enjoying this. Yay for shared experiences. So yeah, the Attack of the Deadly XSS. This is a pick a path story. You can choose your own adventure. And the stories always start with this like really ominous warning, like you and you alone are in charge of what happens in this story. That's kind of true, although managers. But you know, like, don't despair because you can alter the path of your own story. Okay, so your name's Justice, a nice gender-neutral name that you want to have in a book that's targeted at all genders. And you got a trusty list of websites, and you're going to begin your quest. So let's start with a history lesson. JavaScript was invented in 1995 in a alcohol-infused evening by someone who decided to invent something they called MochaScript. And I don't know how many hours or days later it was, but cross-site scripting was invented very shortly afterwards. So we have two choices. Do we understand cross-site scripting?
No.
Okay, cool. That's good, because otherwise we're going to completely skip those slides, and I would have gone, why did I make them? Okay, so let's go to find out about cross-site scripting. Hang on. We don't understand cross-site scripting. Okay, so what is cross-site scripting? Well, first I'll start with a motivator. Cross-site scripting is everywhere. Almost every single web application that I've worked on or tested has had cross-site scripting somewhere. Google, who people pretty broadly agree are one of the best companies at web security, 60% of their bug bounty payouts are for cross-site scripting. Bug Crowd, where people can go and hunt for bugs for money, sort of 20-ish% of bugs are cross-site scripting that are found. And the thing about cross-site scripting is if your application has it, an attacker can inject JavaScript that can do anything that the user can do. So if you manage to get a user to run JavaScript in their browser and they're able to change salaries, the JavaScript can change salaries. It can crawl the website. It can, copy data elsewhere. Anything that the user could do themselves while they're logged in, cross-site scripting can do. Ooh, page 16. And what's the fundamental issue? Well, Tim Berners-Lee, in all his forethought, mixed everything into one giant string. So, he's like, there's semantic stuff like paragraphs and tables. There's content like the words we want to be in the paragraphs and tables, and we'll just jumble that into one string. And then when we put CSS in, we just shove that into the same string, and JavaScript is all in the same string. And the browser doesn't know who wrote which part of the string and which bits are safe. So it has to assume that the whole web page is safe and to render everything that's in the page and run everything. It doesn't know whether the website creator intended for it to say hello or whether the end user somehow managed to inject the word hello into it. Ooh. So if a user enters their name and, their parents were creative with their naming of their child and the name was angle bracket script, then when the page prints out the user's name, that JavaScript will run, which is not what the website developer intended. And the annoying thing about cross-site scripting is that a web page can display data in so many different ways, and to make it safe, you have to use a different way to make it safe in each place. So if you're putting the person's name inside an HTML element, then it can't have angle brackets in it, some other characters perhaps. But if it's in an input tag, it can't have double quotes in it. If it's in a URL, you have to percent encode things like %20, percent whatever. If it's in CSS, I don't know what you have to do, something different to make it valid CSS. And there, in JavaScript, you can't have angle brackets because that would end the script tag, but you can't have single quotes because that would end a name equals variable. And you end up with a combination of all of these because HTML is nested, and so something can be CSS inside an HTML element, or CSS in an attribute inside an HTML element, or like this one here, JavaScript inside an HTML element. So when you're the developer, you're like, well, I've got this person's name. How do I know if it's safe to put on my page? And every time you put that user's name on the page, you have to go through this mental process of, how do I make it safe for this place on this page? It's really annoying. Go back to page 14. Oh, what's happening here? Oh, do you understand XSS now?
Yes.
Okay, someone said no, so we're just going to... No, just kidding. Okay, so how do we fix XSS? Well, the traditional way is to either fix the output or fix the input. So we were talking about all the different ways that you can output data on a web page, or some of them at least, and you can encode the data to make it safe. So you can HTML encode it, or attribute encode it, or URL encode it, or something else to make it safe in JavaScript. That's normally the recommended approach. Or you can fix the input, so restrict your application to only allow a safe set of characters, which is really hard to know because when the person types in their name, how do you know if it's going to be put into XML or HTML or CSS or JavaScript? So how do you know what the safe characters are? Like maybe you could restrict it to A to Z, but then what happens if your user has a name that's not from the English alphabet? So fixing the input's normally hard. Okay, so at this point in our story, have we fixed all our cross-site scripting? Probably not. Let's go to page 20. Okay, keep on fixing it. So Justice, this talk is for people that think they've fixed all their cross-site scripting, because content security policy is just like an extra defense that you'll add. So fix all the stuff you know about now. And mainly that's because not all browsers support content security policy. Okay, now we've fixed it. Okay, so why do we need to fix it first? Well, let's talk about castles. So Lizzie, the queen of this fair country, her bedroom is that middle window in the back of this castle. And they want to protect Queen Elizabeth, so they have multiple defences. So in order to get into her bedroom, you have to subdue the guard who's standing at her door. You also have to get past the guard at the bottom of the stairs. You have to walk across this open courtyard to try and get to the back of the castle. And, archers are guarding the courtyard. You have to get through this metal gate thing. Is it called a portcullis or something? And in the movies, bad guys will try and go through and cut them in half. So that's another layer of defense. There's a bridge. There's a moat, so there's multiple layers of defense protecting poor Queen Elizabeth from attack. But none of these defenses are perfect. The guard outside her door occasionally has to take bathroom breaks. The archers can't fire arrows in the dark. The moat only really protects against 16th century people that don't know how to swim. And so, none of these defenses are perfect, but if you layer them all together, you end up with a monarch who's 90 years old. So this is kind of like content security policy, it's just another layer that you add to your application It's not 100% perfect, but it gets you there, gets you part of the way there. So yeah, obviously you should put content security policy outside the moat. Yeah, try and talk to the beefeaters about that. Okay, so now we're ready for content security policy and the adventure of a lifetime. Do you have what it takes? Cool, you can see this is really engaging. Okay, do you want to learn content security policy or do you want to stop now? Oh, hang on. Okay, did someone say stop now? Cool, okay, so that's my... Oh no, let's do this one. Okay, so what is content security policy? How many people kind of knew about it before they came in the door? Okay, sweet. So you've all found that it's hideously hard to do, I assume?
Not about
Yeah, okay, cool. So the goal of content security policy is to prevent the execution of untrusted scripts. It does other stuff as well, but I'm not interested in that in this talk. And basically the way it works is it separates your code from your data. HTML still mingles them together, but in content security policy lets you tell the browser, this is code that I trust, and you should treat the rest of the stuff as data when you're rendering the page. And so we can separate our code from the attacker's data. The way you do it is by setting an HTTP header. And to get the maximum benefit from content security policy, you typically need to start at the beginning of a new app. It's hard to retrofit, and if you've got an existing app, you probably need to modify the app. So I've got two approaches I want to talk to you about. If you're building a brand new project, or you have the source code of your app, you follow this approach. And if you don't have the source code, and you're trying to add content security policy to someone else's app or an app that you can't modify, then you use the second approach. So we'll do the second approach first. And this is what I call the URL whitelist approach. So basically what you're doing in this approach is you're giving the browser a list of locations that it's allowed to load JavaScript from. So here's an example of a header that says JavaScript script tags can come from the current page or google.com. Okay, let's look about, it's also got object source and base URI, so we'll just look at script source first. So this is telling the browser where it can load JavaScript in particular. And you can either give it a host, like an IP or a domain name. You can give it a scheme, like you can load JavaScript from anything http:// possibly not a good idea. Self, which means the current website. Unsafe inline and unsafe eval, which we're going to skip for now, but there's a clue in the name of those. And none, which is don't load JavaScript from anywhere, don't run it. And the browser will respect your wishes if it understands content security policy. So here's a couple of different examples. The first one, my website will allow any JavaScript from google.com, star.example.com, and 1234. Probably shouldn't paste that in your own website because I don't know what's at the end of that IP address. And then the other one is a bit more open, which says anything that starts with HTTPS. Page 28, what's on page 28? So you need to figure out which external hosts your application uses. And hands up if you know every place that your application loads JavaScript from. You are either extremely lucky or a liar. Hopefully I phrased that in the way that didn't offend you and make you want to leave. Most people don't know all the places that JavaScript comes from. You could ask all your developers. I bet you they don't know. Or you could figure it out. And so what content security policy has is this report only feature. So you make an HTTP header with -report only and give it a URL to report. And when the web browsers run your web page, they will send reports back of all the JavaScript they've loaded. So I'll show you how that works. Oh, so when it's in report mode, the users won't be blocked. They won't know it's happening. So there's this tool. So it's not an open source tool. It's written by Scott Helm, who is a web security blogger, author, presenter guy from the UK. But it does have a free tier, so I figured it's kind of okay to talk about it at OWASP. And I'm not financially involved with it, so I'm not really selling anything. Even though I did used to own the domain name, I gave it to him for free. So contents reporturi.com lets you basically collect these reports and analyze what browsers are seeing. And the way you use it is you create an account, you go to their wizard, and you add basically a header that says, don't let any JavaScript run on my site, and then you see what the browsers tell you. Nice picture of a wizard, eh? Cool, so let's have a look at it. So this is Report URI. I just popped it on my company website the other day. It's only in report mode. Our website doesn't have login, so who cares if it's got cross-site scripting, really, except it'd be really embarrassing for a web security company to have cross-site scripting. But anyway, and what's happening here is the visitors that have been to the site in the last couple of days, as their browsers have run the JavaScript on the site, it's sent reports back to us about where it wants to load the JavaScript from. So this isn't sensitive, but so here is an inline script that 33 Chrome and Windows browsers, I guess that's probably Edge, browsers have been asked to run by the website. So they've all reported back to say this script, which looks like it's something to do with Google Analytics, has attempted to run on the site. And you can see, these URLs that it's loaded JavaScript from. The other thing you see, interestingly, is that all sorts of random JavaScript runs on your own website that you don't expect. So somewhere down here, I saw earlier, one visitor to our website is running JavaScript from gateway.zscaler.net when they're visiting our page. And that's probably like some sort of corporate proxy that's man in the middling and inserting JavaScript. That seems evil, but I guess they probably work for a government department, so they're used to evil. 4 people had that. You see like plugins, like browser plugins will shove random JavaScript into people's web pages, so we get reports for that. And the report URI tool tries to trim them out. And it gives you a list of basically all the things that it's seen in this wizard, and you can build up a new policy saying, I trust Google Analytics. Oops, I'm lost. Must have logged out while my browser was sitting here. And it'll give you a new policy that you can use. So you basically use the wizard to come up with a new policy. And do I have a picture of that? And so here's the new policy where I'm like, okay, now I trust Google and Google Analytics. So the way that I recommend you do this is just put the report URI on your dev version of the site, get everyone on your team to browse around the website, and hopefully you build up a reasonable list of all the stuff that you use, like YouTube and Google Analytics and any other stuff. And then once you've done that, go live with the policy and then rinse and repeat as customers come in. And then when it's stable, you could potentially turn off report only mode and actually start blocking JavaScript that's not in your whitelist. Okay. So we're still talking about whitelists. There's 2 other tags, object source and base URI, that you probably also want to block. So object source is Flash. Luckily, Flash has been dead since the Dark Ages. So most people can just say, don't allow Flash. And base URI is a fun one. So do people use base tag in their web pages? It's like a weird 90s feature where you can say every URL on my website, instead of going to mysite.com, load it from some other URL. So if the attacker can insert a base tag into your site, then all your JavaScript will load from attacker.com rather than your own site. So you probably want to turn that off. Okay, to proceed to more advanced topics, go to page 34. It's exciting. So what can go wrong? So we're talking about this whitelist approach. I've already kind of foreshadowed that it's not the best approach, and it's only if you can't fix your own application. But you probably want to avoid some things like whitelisting half the web servers in the world, or adding inline script, or eval. But it turns out that most web apps have inline JavaScript and use eval. Sometimes people use eval to parse JSON. They're living on the edge. And, you know, like you've got on-click handlers for images and stuff like that. So you probably need to rewrite those bits of your app, or you might end up having to allow unsafe things. Still better than nothing. But the other problem with it is that the whitelist approach is fundamentally flawed, because you're saying you trust everything under www.google.com, gstatic.com, and Google Analytics. That's what's required just to get that JavaScript beaconing. And most of these services that you trust have other JavaScript on the same host name. So they'll have JSONP endpoints where you can just put JavaScript in the question, in the URL parameter, and then that'll run when the script tag loads. They'll have Angular, I think, is the JavaScript library that is quite easy to have cross-site scripting issues in. They'll have old versions of jQuery as well as the new versions. So it's kind of fundamentally flawed to just have a URL whitelist. But it's still better than nothing, right? Like, I mean, Queen Elizabeth has survived all this time, not because a moat is a perfect defense, but because it's an additional defense. And this might be the best approach you can do. But if you're going to go and rewrite stuff, you should aim for strict CSP. So let's go back and choose that path. So if you're building a brand new project, it's the perfect time to adopt strict CSP. You'll have to use a different templating engine that can insert nonces. We'll talk about that. Have to not use inline event handlers and avoid using eval. But, you know, if it's a greenfields project, you might be able to convince people to do this. And, you know, JavaScript developers like making things harder anyway. And so they'll take an on-click handler and turn it into a 30-line JavaScript snippet. So it's good. So let's go find out about strict CSP. So strict CSP is a version of content security policy that was coined by and used by Google researchers. So they found it really hard to use the whitelist approach for their apps. So when they were rolling out CSP, they had troubles. And the kind of troubles they had are the same ones that I had and probably you would have with a whitelist approach, and that you end up with a huge whitelist and there's lots of stuff that you have to include in your whitelist that are actually unsafe. So rather than using a whitelist, there's a link which you'll be able to click on when you download the book to more information from Google. Instead of using a whitelist, I use something called a nonce. And a nonce is basically just a random string that the attacker doesn't know. And anytime you put a script in your page, you put the secret string in the script tag. The attacker won't know what it is. I mean, they might know this one because it's 42 base 64 encoded, but you might have a more secret than my secret, because, you know, a secret is better than a not secret. Anyway, and so when the browser loads this page, it will only run the ones that have the correct nonce on them, and it won't run any other script tags. So if an attacker manages to get a script alert into your site, it won't run it because it doesn't have the right nonce. So the way that you tell the browser what your nonce is you put it in your content security policy header. So on the server side, you generate a random number, you add it as a header to tell the browser what the random number is, and then you scatter that random number through your HTML, telling it, you know, here's this giant string, these are the bits that are code, and the rest you shouldn't run. The rest is data. And I've got a note here that it should actually be random, just in case you go home and use 42 as your random number. So now this is really good because you can just mark bits of your page as safe, and the browser can run them, and attackers don't have control over those bits. No more cross-site scripting. But it's your responsibility to make sure that those bits that you've marked as safe are actually safe. So if you're including a link to your own JavaScript library, you'll actually need to be checked for cross-site scripting. If you're outputting some stuff, you have to make sure you encode it before you output it. So it doesn't completely absolve you of any burden, but it helps. Hey, I've noticed that in Melbourne there's lots of bugs. Is it weird? Like in Wellington, it's too cold for bugs. I don't know. Yeah, it's just walking along and it's like boom, boom. It's very weird. Yeah. So what are we doing here? Okay. And the other problem you'll have is that your library might include other JavaScript libraries, and so this is a trend in modern JavaScript development, I guess, where you use things like require and other kind of bootloading JavaScript styles, where you'll load one script and it'll load other scripts. And we saw that with Google Analytics. Like we just included ga.js, but that was also including some random JavaScript from google-analytics.com and gstatic.com. And so when those ones load, should the browser treat them as safe, or should they be untrusted? What you need to do is use this tag called strict dynamic, and that will tell the browser that your script that you've said, ga.js, is safe, and any of the child scripts that it loads, you trust them as well. So the strict dynamic basically allows scripts to be added dynamically to the page as long as their parent is something that you've trusted. And what Google found was this is basically the only way that they could get content security policy to work at their scale, is to basically have a trusted script at the root, which they told the browser to trust, and then let that load whatever it needs. So they do have a good website where you can understand the nuances. They link to some academic-y papers as well as some real-world stuff. And they've gotten basically most of, I think, their apps locked down using this technique. And I think they were saying that of the cross-site scripting that's found now in Google websites, about 75% of the issues would have been blocked by a strict dynamic CSP policy. So there's still stuff that content security policy wouldn't stop. So, like even if you're perfect like Google, but, it's better than nothing. Well, it's 75% better than nothing. Cool. And the other thing that I said before is you have to get rid of inline event handlers. So, like back in the 90s, this is how we wrote JavaScript. href equals JavaScript : It was really easy. But now what you need to do is like add event listeners and stuff, and then blah, 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 and then eventually your function runs. I don't know, it does my head in. But, you need to do that. And I think probably if you're doing brand new apps, you're using that style of event handlers anyway. So this is because the browser won't know that these are safe. They won't know if it's got the right nonce. Okay, so you've got there. You've followed this path. You now have a strict content security policy. Turn to page 44. Wow. You got to the end of the book. You can choose the next adventure. So we've covered two different approaches. There was if you didn't have the source code or the ability to change your app, you would use the whitelist approach, which I think is more like the original way people would have tried to use content security policy. But I've outlined some of the problems with that. And if you're doing active or new development, you can use the strict approach. I've got 25 minutes. The next slide I'm going to talk a lot to fill it up. No, just kidding. So what's in your inventory now? What have you taken away as an adventurer? Well, I didn't introduce these two left-hand tools, but they are some tools that you can use to help figure out what content security policy might work for your website. And the evaluator will, you paste your policy in and it'll say, actually, this is not actually as strong as you think it is. Report URI is the free but paid application we use to build up our whitelist. The Google Content Security Policy introducing strict dynamic, and of course on the developer network formerly called Mozilla Developer Network, now contributed by Microsoft as well, there's information about content security policy. So hopefully that'll be a grab bag of stuff that you can click on. And you've completed your quest. You've vanquished all your XSS. You've fortified your sanctuary. I'm so creative. And you've made it hard for XSS to return. You've made the world a better place. What have we covered? Well, we've covered what is XSS, what is content security policy, covered the two approaches, whitelisting hosts and the strict dynamic approach, and giving you some tools. And now if you look back at that list of websites that you wrote on that dead tree, you've got two different approaches that you can use to apply some defense in depth, depending on whether, first off, do you even care about the site? Does it have login? Is it sensitive data? And then do you have the ability to modify the source code or edit the templates, or do you have to use a whitelist because you don't have the ability to do that? Cool, that's the end of the story. You made it to the end and you're still alive. This is unlike a normal picker path. Any questions?
I've got one question.
Okay, just yell it out and I'll repeat it.
Yeah, so...
Okay, don't yell it anymore.
So just regarding the nonces, you were saying you would generate them when you render the HTML.
Yeah.
But if you were... So is that with like every page request that you get? Because then how does that like work if you were caching?
Yeah, okay, so the question is, do you render the HTML and how does it work with caching? Right, so you're giving an HTTP header with a nonce and you're giving HTML that uses the same nonce. Every page load you should have a different nonce because you don't want the attacker to know it. But the way a cache normally works is it'll return the same headers and the same HTML. So CSP will still work. I guess it just means that the attacker has a higher chance of knowing what the nonce is if it's being cached. But I know in my experience, normally applications that cache content tend not to have the sensitive data login aspect. So I think you probably still work. And the other thing, I guess, is that some pages, some like single page apps, the HTML is actually pretty static. And the page is built up dynamically, and so then I guess you'll need to use JavaScript you need to give the JavaScript the nonce, and it will need to write the right script tags into the page with that nonce. So you'll need to figure out how to protect that from attacker injected stuff. Yeah, I think it still works.
Yeah.
Fake. Cool. Question 2.
Can you report and block at the same time?
Yes, sorry. So the question was, can you report and block at the same time? And totally. You can put as many content security policy headers as you want. Here's one I prepared earlier. Buy our stuff, blah, 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 work for us, whatever. See, that just justified the plane ticket. So here I've actually got 2 report-onlys headers, because if it's tiny, because I wanted to use the wizard and the other thing in report URI. You can have multiple ones without report only. I think how it works is the browser has to enforce all of them, so you kind of end up with the intersection of all the security restrictions. But yeah, you can put more than one. It's a long answer. Yes. Yeah, cool. That's the short answer.
Have you had a look at whether the different browser vendors implement different parts of CSP?
Yeah, and traditionally, do different browser vendors implement different parts of CSP? Yeah, traditionally that has been a pain. but they're kind of converging. So when content security policy first came out, I think it was about 2011, different browsers were implementing different parts of it, and they were using like X-content security policy because it was experimental. But they're kind of converging now on a similar feature set. There's multiple versions of CSP, 1, 2, and 3, and I think, do they all use 3? I don't know if can I use says. But on the other hand, the other thing that's happening in the browser ecosystem is they're all just using Chromium. So for better or for worse, now Firefox and Edge inherit the same behavior. But there is also a way of writing content security policy that'll downgrade to older browser versions. I haven't covered it, and it's kind of a bit hard to get your head around, but you can have a strict dynamic policy and then a fallback to a whitelist-based one if you want to support older browsers. But because content security policy is a defense in depth feature anyway, I mean, say 5% of your visitors were using older browsers, in theory there's no cross-site scripting issues anyway, and in practice, if there is issues, hopefully the other 95% of your users will encounter them, report back to you, and you'll see it show up on your reporting URL. So, yeah, that. I'm not really good at like summarizing my answers. Yeah, question down the back. Cool.
So in your experience, how many iterations of sort of report analysis, implementation and so on would you go through to reach a strong policy? And if you were asked to estimate the effort required, you know, to do that up front, what would your average be?
Yeah, so in my experience, after a few months, you give up. And if you really persist, I think you'd take a few iterations. The nice thing about doing it in report-only mode is it doesn't affect anybody. I mean, they do see... Oh, where's my browser gone? They do see stuff in their console, which is kind of icky.
Yeah, that's what we've done, and the client doesn't like it.
Yeah, and so blocked. Is this the one? Blocked by client? No, that's actually my ad blocker blocking it. Anyway, you do see it in that console, so it's kind of icky. And no one provides consulting services, as far as I can tell, to help you write a content security policy.
Yep.
So it's quite hard to get advice on how to iterate it, which is kind of why I wanted to do this talk. I think content security policy has a sampling mode as well. Now I'm just randomly Googling stuff. I shouldn't do that in front of people. Who knows what will show up. But yeah, I think there's a sampling mode, and I think you can potentially just put the header out for certain users of your app or certain IP addresses if you don't want to do testing on your whole customer base. But yeah, I'd say for an existing app to develop a whitelist, you're probably looking at a few weeks to gather the reports.
Yep.
If you wanted to do the nonce-based approach, then you'll be worried about all the weird corners of your app that don't use the templating engine you think they do to output HTML.
But that's your gold standard, right? I mean, that's...
Yeah.
And so I've got one more question as well. Do you apply a different sort of analysis principle to a vanilla CMS-driven website, for example, versus a React.js single-page app, or would you end up with the same header for both?
That's a good question. I mean, assuming that they were both like the same level of sensitivity, I would probably use a similar technique in terms of analysing, either which host to whitelist or whether I'm not injecting nonces into the page in the right place. I don't think I use any different techniques. I do find that CMSs just tend to have a lot more JavaScripty, like false positive-y issues, which is just a pain in the butt. But normally they don't have as much sensitive data in them, so you can kind of trade off. Yeah.
So then you'd balance the effort against the data sensitivity, as you said.
Yeah, I mean, that's kind of how I approach it. But I mean, it depends on your company and how many layers of defense you want to put in and how much it's going to cost you. Everything in security is like you just do as much as you can afford,
Yeah.
and there's no perfect answer.
Cool. Thank you.
Yeah, sorry.
Any more question?
Kia ora. So,
Hey.
is there a way to cut down the CSP violations coming from the plugins, browser plugins? Is there a direct?
Yeah, so I mentioned that. That's a real pain in the butt. If you have your own report endpoint, which is basically just as simple as something that receives JSON and saves it, then you get a lot of noise. And that's why people have started making tools like Report URI. And what they do is they have filters. So Scott's one, it filters out browser extension ones. So he's looked at, what are the snippets that show up in here that is actually someone's doing weird stuff. So what are the snippets in here that indicate that you're just using Ghostery or some other plugin, and then he'll filter them out because there's nothing you as a developer can do about that. Also, there's some things that aren't actionable. You can't actually fix someone's Z-scaler. You can't, if the report comes in and it has no context, because some of the older browsers didn't send much context, you can't do anything about it. And so he tries to filter it down, and then also sounding like a sales pitch, isn't it? But also the way that he groups it is to try and get, unique ones. So here's one that's got lots of violations. Most of these are only small numbers, but this is 10, and he's kind of grouped them together to say, it's kind of the same issue, even though some of them are from Chrome and some of them are from Edge. But yeah, if you're doing it yourself, it's a pain, and I realize some people can't use third-party services to collect random JSON snippets from all their users. Wouldn't expect a bank, for example, to be okay with that.
Cool.
I don't know if there's open source projects that'll help with that either. Anyone know? Yeah.
Anyone?
Cool. Yeah, keep asking questions. Make it look like I prepared a 50-minute talk.
Have you looked into running this reporting through like a CI/CD test environment, like when you're running your functional tests or something?
So
like that?
can you do? I haven't done it, but I could see how you could do content security policy testing as part of CI/CD. So basically, how I'd do this is like the 30-second idea is have it pop up the test version of your website, and then use a headless Chrome style thing that crawls the whole site, and then see what violations get triggered. And if you're using Selenium or something, you might even be able to attach to the event where it's triggering, rather than having to have an external server that you connect to. Scott on his blog, JavaScript. Oh my goodness, I can't type in front of people. JavaScript CSP has an example of how you can actually catch the violations in JavaScript. So how that works is, I don't think he actually shows how to do it. Anyway, it's possible. There's like an event that fires in the JavaScript that you could potentially catch in Selenium. But then probably the problem is going to be writing a crawler for your whole site. So I guess if you have an existing CI/CD that's doing that, you might be able to hook into that to catch violations.
Thanks.
Cool. Thanks for all the questions. This is cool.
Is each one of those CSP reports, is that a different post out, or does it summarize it in one big post?
That's a good question. So I think how the browser works is it sends each report as a separate post to your website.
Might be browser specific, right? Or
I don't think it bundles them up. I don't think it's like DMARC. So let's just try it.
So you could see, 100 posts.
Yeah, so this one page is loaded, and there's 1, 2, 3, 4, 5, 6.
Yeah, okay, yep.
7, 8. So, it's doing lots of individual posts for each resource. If you follow browser security features, particularly Chrome is doing heaps of cool stuff. There's a new one called network error logging, and that does group them up, but I don't know whether that works for content security policy, and that's pretty new. So release 69, there's only a couple of releases ago. So yeah, it can be quite chatty.
And it's asynchronous, so you're not going to see the browser lock up when it fails to post?
Yeah, that's right. It's asynchronous. So yeah, no user impact apart from if they go into their console and go, what the hell? But with modern web apps, if you go into the console, you always say, what the hell? So what do you mean 30 megabytes to load the homepage? But back in the 90s, it was 15 kilobytes. Cool. Oh, more questions. Cool.
Is it supported by thick-line applications like Electron, wherein they use a web view or an iframe?
I don't know. Yeah, that's a really good question. I haven't done much with Electron apps for a few years, so
Can you restrict it just based for the iframe? Like, are there policies just for that?
Are there policies just for iframes? So, you choose when you return the header, which the browser then enforces. So if you're controlling the inside of an iframe, you could decide whether to return a content security policy header. And there's also, it's iframe related, but I don't think it answers your question. There's other content security policy directives that I haven't talked about, like if you are inside an iframe, you can say who's allowed to put you in an iframe. So you can kind of, that X-frame option's kind of on steroids. You can say these are the parents that I allow. So your content security policy does do some other stuff as well. But as far as Electron goes, I don't know. Cool. Last question?
Last question.
Yeah, getting scared? Like getting harder?
Those libraries like Google you mentioned, actually how vulnerable are they? So is it really such a big threat to whitelist those like open libraries?
Yeah, so really how vulnerable are third-party libraries? Well, log into your internet banking and see if it uses Google Analytics. It's a risk decision. It probably doesn't. I think, I'd probably trust Google Analytics more than I trust, random JavaScript hosted at jsfiddle.net or something. But particularly when you're whitelisting hosts, like a lot of those JavaScript CDNs have old versions of all these libraries. But yeah, any external dependency you add is a new attack vector. So yeah, it's hard. Yeah. Cool. Okay, I'm going to wrap up there, I think. Thank you very much for all your questions.